You know, you see those robots in movies, the really smart ones, navigating tricky places, making decisions super fast.
Yeah, total sci-fi stuff. Or, well, it used to be.
Right. But then think about the AI we use every day, like chatbots or music suggestions. They're smart, sure, but they're just code stuck in the computer.
Exactly. Purely digital.
So what connects that digital brain to, actually doing things in the real world?
That's the big question we're tackling today.
Welcome to the deep dive. Today we're getting hands-on, sort of, with physical AI.
We are indeed. We've gone through quite a bit of material, different sources, trying to really pin down what physical AI means.
Looking at definitions, what makes it tick.
Its characteristics, how it actually works, comparing it to other AI examples, and what's coming next.
So the goal here is to unpack what makes physical AI different, why people are calling it like the next big step for AI.
Yeah, moving intelligence out of the abstract and into, well, physical stuff, embodied intelligence.
Okay, let's start there. What is physical AI fundamentally, based on what we've read?
Well, the consistent theme is AI systems that directly, interact with the physical world. They perceive it, they act on it.
Directly. That's the key part, separating it from traditional AI.
Precisely. Traditional AI lives in the digital space, processing data. Think chatbots, language models. They're powerful, but they can't, pick at a coffee cup or drive a car.
They don't have a body, essentially.
Right. Physical AI is embodied, it's housed, as some sources put it, in actual physical machines. Robots, autonomous cars, smart devices.
Things that exist physically.
Exactly. And you might hear other terms too, by the way. Things like physical agents or embodied AI. They're all pointing towards this same concept.
Okay, so it's intelligence in a physical form, but it's got to be more than just like sticking a chip in a robot, right? What are the defining characteristics?
Good point. Yeah, just having a body isn't enough. There are some core traits. First, as we said, that direct interaction with the physical world.
They're not just watching.
Nope, they're actively engaging. They use sensors, cameras for sight, LiDAR to map things out, microphones for sound, maybe temperature gauges.
Like giving them senses, digital senses.
Pretty much, to gather real-time data about what's around them. And then they use actuators, robotic arms, wheels, motors, to actually do things based on that data.
So they sense, and then they act. What else?
Second key thing is autonomy. These systems can make decisions and act on their own, often without a human constantly telling them what to do.
They figure it out themselves based on the sensor input.
Largely, yes.
Yeah.
Based on their programming and, importantly, what they've learned over time.
Which implies they need to think pretty fast, I imagine. The real world doesn't wait.
You got it. That leads to the third characteristic, real-time perception and reasoning. The physical world is, well, messy, dynamic, unpredictable.
Yeah, things change quickly.
So the AI has to process that incoming sensor data and react, like right away. No time for buffering if a delivery drone spots a kid chasing a ball.
Right, the stakes are higher in the physical world. And they improve, presumably. They don't just run the same program forever.
Definitely not. That's the fourth point. Learning and adaptation. This is huge. They use machine learning, complex algorithms to learn from their experiences.
Like we do, but, digitally.
Kind of.
Yeah.
They analyze outcomes, spot patterns, adapt to new situations, and get better over time. It's not just following rules, it's evolving.
Okay, so direct interaction, autonomy, real-time thinking, and learning. That paints a clearer picture. How does this all work together in practice, that feedback loop idea?
Yes, it's all built around a continuous feedback loop, a cycle. Perceive, process, decide, act, and then learn from it.
Let's walk through that loop. Step 1, perceive.
Right. Perception. The sensors, cameras, mics, maybe touch sensors gather raw data. What the AI sees, hears, feels.
It's raw information streaming in. Then what?
Then processing. The AI algorithms take that raw data and try to make sense of it. What patterns are there? What objects are nearby? Is something moving?
Interpreting the sensory input.
Exactly. Using those machine learning models to understand the scene.
Okay, it understands or thinks it understands what's happening. What next?
Decision making. Based on that understanding, the system figures out the best action to take. This might use those learned models or maybe some built-in logic.
Given X, the best thing to do is Y.
Sort of, yeah. And then it actually does Y. That's the action phase.
Using its actuators, arms, wheels, whatever.
Precisely. The actuators execute the chosen action. Moving an arm, turning a wheel, adjusting a grip. This action changes the environment, or the AI's position in it.
And that change creates new information for the sensors.
Bingo. Which feeds right back into perception, starting the loop again. But there's one more crucial part.
The learning.
Yes, learning. After the action, the system analyzes the result. Did it work? Was it efficient? Anything unexpected happen?
Ah, so it evaluates its own performance.
Right. And uses that feedback to update its internal models, tweak its decision-making for next time. It's this constant cycle sense, think, act, learn, that lets it get smarter.
That makes a lot of sense. Okay, so we know how it's different from purely digital AI. But what about generative AI, like the ones creating text and images? That's also huge right now. How does physical AI stack up against that?
Good question. They're really quite different beasts. Let's compare a few things based on our sources. First, the obvious one, environment.
Physical AI in the real world, generative AI in the digital world. Got it.
Exactly. Then input. Physical AI uses sensor data vision, sound, touch, LiDAR readings. Generative AI uses digital stuff, text prompts, images, databases.
Different kinds of information coming in and going out.
Output reflects that. Physical AI produces physical actions, movement, manipulating objects. Generative AI produces digital content, text, code, pictures.
A robot moving a box versus a program writing a poem. Clear difference. What about independence? Autonomy.
Autonomy is generally much higher for physical AI. It needs to react independently in real time. Generative AI's autonomy often depends on a human prompt or interaction to kick it off.
It doesn't usually just start writing on its own.
Not typically, no. And then there's embodiment. Physical AI has a body, a robot, a car, a device. Generative AI is fundamentally software.
No physical presence.
Right. And finally, adaptability. Physical AI most adapt to the messy, changing physical world. Generative AI adapts based on the data it's trained on, but not usually to, say, a sudden rainstorm, unless that's somehow represented in its input data.
So physical AI is really about that dynamic interaction with the environment itself. One source also mentioned who or what it interacts with. It's not always people, is it?
That's a key insight. Generative AI often feels like human-to-machine interaction. You ask it something, it answers. Physical AI is often interacting with the environment, sensing obstacles, navigating terrain, manipulating objects, regardless of whether a human is directly involved right then.
It's focused on the physical task, not necessarily the conversation.
Exactly.
Okay, this is really clarifying the unique space physical AI occupies. Let's ground this in reality. Where are we actually seeing this stuff work? Give us some examples.
Oh, it's already out there in quite a few places.
Huh.
Robotics is probably the most obvious. Think factory floors, industrial robots doing assembly, welding.
Yeah, we've had those for a while, though.
True, but now they're getting smarter. Warehouse automation is huge robots, sorting packages, moving pallets around, those little robot vacuums like Roombas. That's a simple form of physical AI navigating your living room.
Right, navigating and cleaning autonomously.
Then you have collaborative robots, cobots, designed to work safely right next to people. And things are getting way more advanced surgical robots performing minimally invasive operations with incredible precision.
Yeah, I've seen videos. The dexterity is amazing.
It really is. And humanoid robots are getting closer to reality, designed for more complex human-like tasks.
Beyond robotics.
Autonomous vehicles, definitely.
Yeah.
Self-driving cars, trucks, delivery drones, they're all using sensors and AI to perceive the world and navigate through it. That's physical AI in action on our roads and potentially in our skies.
Still ways to go there, but the tech is advancing.
For sure. And it's not just things that move. Think about smart infrastructure.
Like smart cities.
Sort of. Adaptive streetlights that dim or brighten based on traffic or pedestrians. Building systems that optimize heating and cooling automatically. Even robots in hospitals delivering medicine or assisting patients.
So it's becoming embedded in our surroundings, too. Were there specific capabilities mentioned in the sources? Like, what can they do?
Yeah, specific examples like AMRs, autonomous mobile robots, navigating busy warehouses, dodging people, and forklifts. Robotic arms, manipulators, adjusting their grip automatically for different objects on an assembly line.
Delicate versus heavy.
Right. And those surgical robots we mentioned, performing tasks like suturing at a level of detail humans might struggle with. It really shows the practical application.
It definitely feels like robotics and physical AI are tightly linked, almost inseparable sometimes.
They really are. One source called Physical AI, the true merging of robotics and AI. It's what takes robots beyond simple pre-programmed movements.
So old robots were like puppets on strings, maybe with some basic sensors?
Kind of, yeah. They followed a script or had very fixed reactions. Physical AI gives robots the ability to think based on what they're sensing in real time. They can analyze complex situations and make independent decisions.
And learn from those decisions.
Crucially, yes, They use neural networks, deep learning,
Yep.
to process their experiences and adapt their behavior for the future. It's a much more dynamic and intelligent approach to robotics.
And it's not just the brain, but the body, too, better actuators.
Exactly. Physical AI relies on advanced actuators,
Yeah.
the motors, joints, grippers, that allow for more precise, nuanced, and effective interaction with the world, all guided by that AI intelligence.
Okay, this tech is clearly powerful. But stepping back, why does it matter so much? What's the big picture significance?
Well, there are several big reasons. First, it can seriously augment human work.
Meaning, help us do our jobs better, or take over parts of them.
Both, potentially. Think about tasks that are repetitive, really dull, or dangerous, or require extreme precision. Physical AI can handle those. Delivering meds on time in a hospital, constantly monitoring equipment in a factory.
Freeing up people for other things.
Exactly. Things that require more creativity, strategy, or human interaction. It's also great for data gathering. All those sensors are constantly collecting information about the physical world, which can be super valuable.
And you mentioned dangerous situations earlier.
Absolutely. That's a huge one. Physical AI is essential in hazardous environments. Robots going into fires, handling suspicious packages. AI makes them smarter, more capable in those situations.
Potentially saving human lives by keeping people out of harm's way.
That's the goal. It could eliminate the need for humans in certain dangerous tasks entirely. That's a massive benefit for safety.
Okay, the benefits seem clear. So looking down the road, what's next? What does the future hold for physical AI?
The trajectory looks pretty steep across many fields. In robotics and automation, expect even more capable robots. More dexterity, more agility, able to handle really complex tasks like advanced surgery or intricate assembly.
And autonomous vehicles, you mentioned it's still developing.
Yeah, autonomous vehicles are a big focus. While progress isn't always smooth, the potential is huge. As sensors get better and the AI gets smarter, the hope is for much safer, more efficient transport networks, cars, trucks, drones.
More interaction between humans and these smart machines.
Definitely. Human-robot collaboration will likely expand. We saw the surgical example. Think about other areas where robots can assist humans with tasks that are difficult, dangerous, or require capabilities beyond ours.
Like heavy lifting or working in extreme conditions.
Precisely. Or tasks needing constant vigilance, which ties into environmental monitoring.
How so?
Imagine autonomous drones or robots constantly monitoring factories for emissions, farms for crop health, or remote areas for wildfires or resource changes, providing continuous data 24/7.
That could be huge for things like climate change or disaster response.
Absolutely. And AI-driven manufacturing will get even more sophisticated. Better production optimization, smarter quality control using vision systems, more flexible factory setups, maybe even predicting maintenance needs.
It seems like everything gets more connected, too.
For sure. This isn't happening in a vacuum. Physical AI will increasingly integrate with other tech 5G for fast communication, edge computing, to process data locally on the device.
So the robot thinks faster without sending everything to the cloud.
Exactly. Plus, integration with AR/VR for new ways to interact with these systems and the whole Internet of Things network, it creates a much richer ecosystem.
Building and testing these complex systems must be a huge challenge, though, especially when they operate in the real world.
It is. And that's where simulation and digital twins come in. It's a critical part of the development process mentioned in our sources.
Digital twins, like a virtual copy.
Exactly. Using platforms like NVIDIA Omniverse, developers create super realistic virtual replicas of the robot, the environment it'll work in, maybe even an entire factory.
So they can test the AI in the simulation first.
Precisely. They can run millions of scenarios, train the AI, find bugs, validate its behavior, all without the cost or risk of using the actual physical hardware in the real world. It saves time, money, and prevents potential accidents.
Like a flight simulator, but for robots and self-driving cars.
That's a great analogy.
Yeah.
They use powerful computing like NVIDIA DGX, specific simulation tools like Isaac Sim, even generate synthetic data to train the AI models using things like Omniverse Replicator. Reinforcement learning, where the AI learns by trial and error, is often done heavily in simulation.
And once it's proven in the virtual world.
Then it gets deployed onto the physical hardware, using platforms like NVIDIA Jetson for robots or Drive AGX for vehicles. It's a whole pipeline from virtual testing to real-world action.
Wow. Okay, this has been a really fascinating look into physical AI. If we had to boil it down, what's the main takeaway for our listeners?
I think the core message is that physical AI marks a really significant shift. It's AI stepping out of the computer and into our world. It's about machines that can perceive, reason, act, and learn within the physical environment.
Bringing intelligence into tangible reality. And the potential impact feels huge.
Immense. It could really transform how industries operate, how we get around, how we live our daily lives. It truly changes the game for human-machine interaction in the physical sense.
It really does make you think. As these systems get smarter and more common, how is that going to change our relationship with technology and I guess the very idea of physical work itself?
That's the big question, isn't it? What happens when the things around us aren't just tools, but autonomous agents acting in our physical spaces? What new kinds of collaboration emerge? What safeguards do we need? Definitely a lot to consider as this technology continues to unfold.